Hey team, back to chapter 3 again. So we got through question 2, 3, 4, and 5 are conceptual questions. But with 5, you actually can compute these values without doing it by hand. As you can see, I put in the values. I just called it age because it seemed appropriate for each one that they have listed here. To get the standard deviation, whether it's biased or unbiased, you have to break it into its parts. The first part is the sum total of the mean difference of all the values and the mean of the data set. So the first thing we have to find out is what is the mean of these numbers. So analyze, descriptives, age. Let's find out what the mean is. Hit OK. The mean is 39.44. So just keep that number handy. Write it down somewhere. You're going to need it because you'll forget it. Now, so the next step we want to take, minimize your output, is we're going to start creating new variables. If you looked at the formulas on page 45, 44, you see there are many different components. So what you see in these blue blocks on page 45 is where it's trying to step it out for you on how do you get from this kind of massive looking formula to an answer. And this is exactly what we're going to do. I'm not going to do it exactly the way they do, but here goes. So we're going to compute a variable. Compute. I'm not going to go to target yet, but I know what I'm looking for. It's age, and it's going to be minus 39.44. Okay. And we're just going to call this like step 1. Hit OK. Minimize the output, and you see you have what appears also on the top of page 45. Okay? So we know that 31 minus 39.44 is negative 8.44. We need to get rid of the negative numbers, and that's where the squaring comes in. So our next step is going to be compute another variable. Let's not give it a name yet. And it is going to be step 1 times step 1, because that is essentially how we square a variable. So let's say this is step 2. Hit OK. It's going to create a new variable for you called step 2. Minimize that. And this is what you have. Now, the next step in this process, according to the equation, is that you need to know the sum total of the differences squared, which means that you need to add all these values up. Now, you can do that with a calculator, or I can show you a pretty simple way to do it. You can go to Analyze, Frequencies. What we want is step 2, not age. Stats, you want the sum. That's all you want. Continue. So the sum for stats is 830 to 2. Okay? So now we just have to find the denominator, which isn't very difficult. We know by looking back at our data set that we only have 9 cases in it, and the denominator is the number of cases minus 1. So 9 minus 1 is going to be 8. So again, you can pull up any kind of calculator you want here, and you can put the numbers in. 830.22 divided by 8. And then you can take one of your squaring functions, and it's going to tell you that the square root of that is 10.1857, so. That, my friends, is the standard deviation. So with just a little bit of work in a data set, we can create the standard deviation. Now, why is this important? Because I quite honestly could have gone to this variable right here and gone to Analyze and Descriptives and put age in here and gotten my standard deviation. 10.187, which is pretty much what I found before. The reason we're going through these steps is because you were also asked to produce the unbiased standard deviation. All the unbiased, the only difference between the two is that one is divided by n minus 1 and the other is not. So you need these numbers so that you can calculate that correctly. So we know that the sum of the difference squared is 380.22. In this case, it would be divided by 9. So we can go to any calculator, put the numbers in. 830.22 divided by 9. Hit enter, and then you're going to square that. It's 9.6, slightly lower. As the sample size increases, whether a standard deviation is biased or unbiased really doesn't matter because they almost converge. When you have very small data sets, it could cause some sort of problem in your data set, but it's not necessarily something I would get really worried about. So for this one, you have now figured out how to take one column of data and turn it into 3, and then use some basic math to figure out what the standard deviation is, and also the biased standard deviation. Don't put too much into the biased standard deviation. You're almost never going to be asked about it, and with larger data sets, it's not going to be an issue in any rate. So that is how you get to that particular answer. And from that list of numbers, you should be able to come up with the biased and the unbiased estimators. You can also compute the range, but I think you remember how to do that. If you